Welcome back to the final lesson of Hands-on FPGA Design, from theory to implementation. I'm Albert. Throughout this course series, we have journeyed all the way from basic logic to SoC architecture, and now it's time to bring everything we've learned together for true system-level verification. In Lab 7, we learned how to simulate the master wrapper. In today's Lab 8, we will place the complete SoC architecture, including the processor core and our custom IP, entirely into the simulation environment. Here is the outline for today's session. Before we begin, please ensure that you are fully prepared. For detailed content, please refer to the pre-lab course. There are two core objectives for this lab. First, to learn how to perform simulations on an SoC circuit containing a CPU and observe how the PS interacts with the PL via the AXI bus. Second, we will practice using a pre-configured simulation waveform configuration, which helps us quickly pinpoint key data channels. As for the block design, it continues the architecture from Lab 6. Next, let's examine our experimental circuit. On the left is our circuit architecture for this lab, while on the right is the state flowchart. First, the CPU writes the data to be calculated into the BRAM via the AXI bus. It then writes to the slave register to trigger the master's operation. The master reads the data from the BRAM and feeds it into the ALU for computation. Once the calculation is complete, the master writes the results back into the BRAM. And finally, the CPU reads the final calculated results back from the BRAM. The following is today's experimental workflow. And finally, we will observe the simulation results through the test bench. You can download the required source code examples for this course from the link provided. Let's start our project now. First, launch Vivado and click on Open Project. Select and open our previous Lab 6_ example project. Next, click Open Block Design on the left menu. Here, we need to double-check that both the block diagram layout and the address editor configurations are correct. Once verified, click Add Sources on the left panel. Select Add or Create Simulation Sources. Click Create File. And name the test bench file tb_top. Open the newly created file and paste our provided sample test bench code right inside. Finally, click Run Simulation on the left menu and select Run Behavioral Simulation. Once the simulation window launches, click the Run All button on the top toolbar to run the full SoC test sequence and generate the waveform. Once the waveform appears, we will utilize a pre-configured waveform configuration file to inspect the organized signal groups. To open it, go to the top menu, click File, navigate to Simulation Waveform, and select Open Configuration. Choose and open the provided WCFG file from our sample folder. Here is the demonstration of results for Lab 8. We will analyze the simulated waveform to understand the collaborative computation workflow across the entire SoC system. First, let's look at the MAXIGP0 channel. This represents the channel through which the CPU writes to and reads from the BRAM. The W data signal carries the operand values designated for computation. Next, observe the slave channel. This interface receives the operation count and the start trigger signal transmitted from the CPU. Below that is the master read channel. The master unit fetches the operand data from the BRAM and feeds it into the ALU. Finally, look at the ALU input-output signals, along with the master write channel. The master writes the calculated results from the ALU back into the BRAM, which are then read back by the CPU to complete the entire hardware-software co-design execution cycle. With the final simulation of Lab 8 successfully completed, our Hands-on FPGA Design course series officially comes to a close. This diagram shown on the screen is a special course completion certificate I prepared for everyone. It is a waveform representing commitment and reception. The valid signal represents iVSLAB as the knowledge provider. From Lab 1 to Lab 8, our passion for teaching and the quality of our content have consistently remained asserted at a high level. However, the most crucial component is the ready signal below, representing you, the learners. In the first half of the course, this signal might have fluctuated at a low level, but by the second half, knowledge was no longer just static text on slide decks. It truly integrated into your logical engineering mindset. And finally, both sides achieved a successful handshake, marking a perfect conclusion to this course. I hope that as you venture deeper into advanced domains like SoC design or AI hardware accelerators in the future, you will always maintain your ready signal asserted high. To close this course, I would like to leave you with one final quote. Master the hardware, architect the future. Feel free to visit our laboratory website linked in the bottom right corner, where we will be planning more advanced courses in the future. We are the Intelligent Vision System Laboratory, iVSLAB, led by Professor Jiun-In at National Yangming Chiao Tung University. Thank you so much for watching. If you enjoyed this course series, please feel free to share your thoughts with us and share these lessons with anyone looking to master FPGA design. I'm Albert. Until next time, goodbye.